Hi, I'm Ian Griffiths, and this is a talk from the Building Business Applications with Silverlight series. In this talk, we're going to look at validating user input, a very important thing to do in most line of business applications, and indeed a lot of user interface applications. So Silverlight offers a variety of ways that you can validate user input and provide some sort of feedback to the user that things may have gone wrong. Obviously, you could just write code to do that. You could write code to look at the input yourself and see whether it looks like you want it to look and do things in the UI in response to that. However, there is some built-in infrastructure that can take some of that work over for you. So in Silverlight 3, the only way you could signal to Silverlight's data binding system that there was a problem with the user input was to throw an exception in the setup. And some controls could then respond to that and indicate that there was an error. But in Silverlight 4, we get better ways of doing this. So the data error info interface, which has been a standard feature of .NET for a while, is now available in Silverlight, and some controls can support this. If you bind a text box to a data source that supports this and you enable the use of that validation feature, which you can do in the binding expression itself, you can set the validates on data errors property to true on the binding, then it can provide feedback to tell you there's a problem. There is one issue with this mechanism though. This assumes that the data source is able to know straight away whether the data is valid. So what will happen is the binding will push a change into the control because the user types some new data in, and then immediately will ask, does that look valid? It will use the iDataErrorInfo interface to interrogate the data source object, probably our view model. It will say, is that all right? Does that look okay? And we'll expect an answer there and then. The problem with this is a lot of the time validation can involve work on the server. You might be able to do some validation on the client side. There might be some rules like must not be empty or must supply at least one phone number. Those sorts of rules you can process entirely on the client side. But there are other rules that you can't. For example, if the user's signing up for a new user account, one of the rules you have is the user ID that they pick needs to be unique. And you can't know that on the client side. Obviously, you're not going to upload a list of all known user IDs from the server to the client just so you can check that. And even if you did, that wouldn't work because two users might try and sign up with the same ID at more or less the same time. You're going to have to do certain sorts of validation operations on the server, and trying to do that synchronously, having a mechanism where the data source doesn't even return until it knows the answer, doesn't really work if you're making those decisions far away. And so Silverlight also supports iNotify data error info. And this is a notification-driven thing. It's asynchronous. The source can say at any time it likes, oh, by the way, I've got some validation status for you. So some data you gave me earlier, I've decided I don't like it. And then the control can respond to that as and when you discover this. And again, you just turn this on with the binding. There's a property called validates on notify data errors. And if you turn that on, the control will look to see if the data source implements iNotify data error info, and if it does, then it will respond by changing its visual state in the right way as the data becomes valid or invalid. And this is a slightly better fit for most Silverlight applications because often the real logic lives on the server. Now, there's a built-in class called the data form and a corresponding class called the data field, which can actually do a bit more work for this. Technically, it's part of the Silverlight toolkit, although the rear services toolkit also brings its own copy of this form. And what it does is it can generate a form based on the structure of a data source. The rear services template, the business application template that we're using in the example application, uses this. But as I say, you can use this in isolation. You don't have to be doing rear services. But it uses this to generate the login form and also the user registration form. If you go and look at those forms in Visual Studio, you'll see they don't appear to contain any forms at all. They look like they're on the left-hand side of the slide here. You've got basically a more or less empty form. The login, username, and password fields will appear to be empty. And again, if you look at the register form, it will look the same way. It's generating those fields by reflecting against the data source type and generating a field for each property that it finds in the source. But clearly, there's a bit more to this going on, because it's able to provide labels for the fields, username, friendly name, email, password, and so on. And those are not always the same text as the property name. And in general, you wouldn't want them to be. You don't tend to want to have identifiers from your code making it through to the user interface. It makes localization very hard to do. It makes things like putting spaces in the text hard to do. You tend to want some separation there. And the registration form seems to achieve this. Also, the registration form can provide you with hints. Some of the fields you can see there, like the friendly name and the password, have a little eye icon next to them, and if you mouse over that, they provide a tooltip telling you things about the field. So the password will tell you what the complexity requirements are. It'll say you need to provide a certain number of non-alphanumeric characters or whatever the rules might be. In case of the friendly name, it explains what that's for, and so on. And it turns out that some of these fields will do validation as well. They have validation rules that are applied, and they can be applied on the client side. It can tell you immediately you've got a problem without having to wait for the server to come back with an answer. And all of this stuff is handled by the data form and data field types. So let's take a look at how this actually works. To exploit these features, you can create a class which is marked up with data annotation attributes. This is not specific to Silverlight. This is a feature that was added to the .NET framework, the full framework, back with the .NET 3.5 Service Pack 1 release. Originally brought in to support some ASP.NET dynamic data features, but other bits of the framework have used it since. And Silverlight has had these since version 3. And they provide you with a way of just saying things about your data. You can say, this is the description text that should be applied to this data. You can say, this is the label that should be applied to this data. You can provide an ordering. You can say, these properties should appear in the following order when they appear in a form. You can define validation rules. There's all sorts of things you can apply to your data description. And if you happen to be using RIA services, any model types that have these annotations applied will have those annotations replicated on the client side when the RIA services link provides a definition on the client side to correspond to that type. And if you're not using RIA services, you're free to apply these annotations yourself to your data source objects. So let's take a look at that. I've got a project here in which I've got a grid containing a data form, and I'm going to add a class to my project. I'm going to call this my source. And to start with, I'm going to add just a single public property type string called first name. And I'm going to create an instance of that and give it to that data form. So in my XAML, my data form is called data form. And notice I've turned on auto-generate fields. I'm asking for it to produce a data field for each property that it finds. So in the code behind, let me create an instance of my source. And set that as the data form's current item. The reason they call it current item is that the model the data form offers includes the ability to navigate through a collection of multiple items. So you might actually connect it to a source collection and walk back and forth through those. So the current item represents the object it's rendering right now. Here we're not using a collection, so I'm going to set that directly. So let me run this. So it's displayed a text field that's filling the whole width available because that's the default layout. I just dropped the form in there and said, please take all the space. And its default behavior has been to show the property name because it's not got any other information to go on. I've not told it anything else about this. So it's had to say, well, in the absence of any other instructions, I'm just going to show the underlying name of the property as it appears in the code. But we can do better than this. We can annotate the source. We can say, I'd like to annotate this with the display attribute, which lives in a namespace in a component I haven't added yet. So let me go in here. I'm going to go into the Silverlight SDK. So Microsoft SDKs, Silverlight for libraries client. And in here, there is a system.componentModel.dataAnnotations DLL that's part of the standard SDK. And once I've added that, Visual Studio will offer to generate me a using statement for the system.componentModel.dataAnnotations namespace in which all of these attributes are defined. And then I can do things like set the name property. And if I say first name with a space in it and run this again, now I get a space between first and name, whereas before there was no space there because there is no space in my property name. And obviously I'm free to put whatever I like in here. If I say foobar and run again, foobar is what appears. So I'm now saying, ignore the underlying property name of the code, here's the text I'd like you to use. And by the way, you don't have to hard code the string in here. If you've compiled a resource into your application, if I add a new item, resource file, and let's call this data resources, and call this first name label, and put the text first name from resource in here, and go back to my source. If I use name equals first name label, well, on its own, that will just display literally first name label on the screen. But if I also set the resource type property of this attribute to be the type of the wrapper for that data resources thing I just added, the presence of this tells it, well, actually the name is now an index into that resource file. So I should now find, when I run this, I get an exception. What have I done wrong? What I've done wrong is I forgot to make that a public item. That should be sufficient, and now it's able to pull out the name from the resource dictionary. So it's a localizable mechanism. Gives me the ability to change the strings based on different locales because I'm using resx files which go through the localizable resource manager system, and essentially means I can control the label. And there's all sorts of other things I can put on here. I could, for example, supply a description. And again, because I've got the resource dictionary, this means this will be a lookup into that resource file. But again, it gives me a way of providing, let's call this first name description. You'll see what this looks like when I put this on. If I add another entry to my .resx file, say this is the description for first name, and run that again, it grows a little eye icon to the right-hand side. And if I mouse over it, I get a tooltip that displays me the text that I just put there. And there's various other things you can put in here. You can control the order. You can control the text you can see here. There's various things you can add. And there's other annotations you can add for things like validation and so on. It's a fairly large world, but basically, if you go and look in the documentation, you'll see all the different annotation types that are available. So the data form provides us with a way of generating forms with fields for each of the properties made available by a source, and then we can use data annotations to control how those appear and to provide client-side validation for things like must be present and regular expressions and so on.